is an integral part of any successful FRC team. Well-crafted code can be the difference between success and failure on the field.
But what does it mean to program your robot? Well, here are some of the basics.
First off, your programming team must select which language they will use to program your robot. Currently, 3 languages are available: C++, Java, or LabVIEW. Which one you select depends on many factors, such as the background knowledge of students and mentors and your desire to customize every facet of your robot.
The major differences between C++ and LabVIEW, the most obvious difference is the graphical nature of LabVIEW versus the textual nature of the source code of C++. Some of the advantages of using LabVIEW is it is a protected environment and you're not exposed to pointers, and you will have a little easier time with syntax and errors in your programming, not causing you as much time waste because you have to reboot the controller and figure out what's going on and why it's crashing. On the other hand, C++ is another industry standard language and offers the power teams ultimate flexibility. Another benefit of using LabVIEW is the debugging capabilities, although this year they have source level debugging in both environments.
LabVIEW was designed for non-programmers. It offers a visual way to configure your robot code by dragging and connecting building blocks called VIs. C++ and Java are both textual, object-oriented languages. C++ offers slightly more customization possibilities, but Java is generally a bit easier to learn from scratch.
In the end, there's no wrong choice. Every language is capable of producing a winning robot, but you will want to at least learn the basics of one of them. Although the default code can get you up and running, you will definitely want to be able to tweak your robot's performance through programming.
Once you have selected a language, you will want to monitor all the available online resources to find updates, patches, and user manuals for your programming language and the C-RIO robot controller. In some cases, your robot may not be able to communicate with the field software if it is not up to date. User guides and tutorials are available for all the languages from the official FIRST website. For answers to specific questions, there is no better resource than chiefdelphi.com, the unofficial discussion forum for all of FRC.
Your team will have to write 2 types of code. The majority of a match is played in teleoperated mode, where drivers control their robots by sending wireless commands from joysticks and buttons. For the most part, teleoperated code will consist of simply mapping joystick axes and buttons to various functions on your robot.
In autonomous mode, however, it is time for your programmers to shine. In this 10 to 15 second period that has begun each match since 2003, robots can use only pre-programmed code and sensor inputs to move about the field. In some games, a reliable autonomous mode can turn a good robot into a great one.
Your kit of parts will come with all the electronics necessary to connect your robot to your player station and programming laptop. It usually comes with many useful sensors such as gyros, accelerometers, encoders, and a camera.
Some games incorporate a vision target that the camera can detect. By tracking these targets, the robot can aim a mechanism or give feedback to the driver to tell them that they are lined up. The default code does support the camera, but it can require some tweaking to get perfect. You should weigh the benefits and risks of planning to use it extensively before getting too far into the build season.
The programming team should begin work immediately after kickoff. Think carefully about what your code will need to do and plan out what you think it should look like. Sensors or input devices can be programmed before the robot is complete.
As the build season progresses, your programming team should keep up with the progress of your mechanical build team and tweak the code accordingly. This will lessen the amount of work needed at the end of build season and keep your programming team's stress levels under control.
I think a lot of teams find that the build period really is you have 5 weeks where you get X amount of work done, and then the last week where you get 2 times of that done. It's just compressed schedule. So the more that teams can do up front and spread out through the season, I think the easier it will be for them to accomplish their task. So I guess don't wait till the last minute. Get started early.
When at competition, the programming team's main responsibilities are ensuring that everything is working correctly and tweaking things to improve performance. sometimes you will want to change your autonomous modes depending on your strategy for any particular match. Planning a way to do this ahead of time will save you a lot of stress on game day.
And finally, the great thing about the FIRST community that you are now a part of is that there are tons of resources available to help you out. We have compiled a list of important and ever-growing resources on our website at www.team341.com/resources.